E.T. phone home.
Did you know that E.T. couldn't have actually phoned home using sound waves? Hello, and welcome to a new edition of Coloring Edge Science, the podcast. Well, it's time for us to move into our final unit of the year, and in this unit, we're going to find out about why E.T. couldn't have actually phoned home using the sound waves that we know about. For the next couple weeks, we will be learning about waves.
And the waves, they remind me of the past. I love that.
We've already learned a little bit about ocean waves, but in this unit we'll be exploring many other natural phenomena, like sound and light. So let's start by introducing you to what a wave actually is. A wave is a disturbance that carries energy without carrying any matter. When a soccer player kicks a soccer ball filled with energy, it flies across the air. This, however, is not a wave, because the soccer ball, which is matter, is moving along with the energy. An ocean wave is only a wave, because the water molecules are not actually moving along with the energy. They are just moving up and down. There are two major types of waves, and it is important to distinguish them. Mechanical waves are those that require matter for the energy to flow through. The second type are electromagnetic waves, which don't need any matter to travel. In fact, they can travel right through empty space. Let's first start by talking about mechanical waves. Mechanical waves come in two forms that are differentiated by the movement of materials as the energy passes through it. Compression waves have the matter move in the direction of the energy. They don't keep going with the energy because the molecules just end up bouncing off of each other. Thus, you are just left with areas of high and low density as shown in the figure above. Transverse waves are most likely the types of waves you are used to seeing. In transverse waves, the molecules bounce up and down in a perpendicular motion to the direction of energy travel. Some common examples of waves that you are aware of that travel in a compression form are sound and alternating current electricity. The figure shown on this page illustrates how areas of high and low density are formed because the molecules inside the matter are bumping into each other as a result of the energy passing through. One common example of a wave that travels as a transverse wave are the waves that you see in the oceans and in the water. The figure shown in this page illustrates how the molecules bounce up and down and to form areas of high and low density, but in this case they are going up and down and not right to left. Some mechanical waves need matter in order to transfer energy. They can't work in space where there is no matter. Therefore, how did E.T. ever phone home? He couldn't have used sound waves because they require matter to travel through. So what kind of communication could E.T. have been using? Well, this brings us to the form of waves that do not require matter. Electromagnetic waves. This type of wave can travel right through empty space. You may not have realized it, but every time you are looking at something, you are being bombarded with electromagnetic waves. In fact, it's electromagnetic waves that are responsible for you being able to see different colors. The background of the screen is yellow. This means it is giving off electromagnetic waves of a 600 nanometer wavelength. If the wavelength were to shrink and become 400 nanometers, you would see the screen as the color purple. The same is true for the color of the t-shirt you are wearing right now. You could only see that particular color because the sun's rays or your room's light bulbs are shining light on it, and it is being reflected back to you as waves. If your t-shirt were somehow to reflect a different wavelength or light back to you, you would see a different color. Well, that concludes this edition of Cutting Edge Science, the podcast. So until next time, keep wondering.
And the waves they